Let's begin our discussion of parabolas with this one. Graphed in red, y equals x squared. Well, we see the obvious, the vertex down here at the origin, 0, 0. And perhaps you've drawn this before, and you started by finding the integer values the graph passes through. 1, 1, let's see, 2, 4, and 3, 9, and of course 4, 16 up here. On the other side of the y-axis, that would be negative 1, 1. Negative 2 squared is also 4. Negative 3, 9. And of course, we could have negative 4, 16. And of course, that's because the y-axis is the axis of symmetry. The axis of symmetry, so every point in the first quadrant is reflected into the second quadrant. Okay, well, yeah, we already knew that. But now I want to say, let's change it to this form. Y equals ax squared. Well, in the case of the red one, a is 1. But let's change that a little bit. Let me take this graph and I'm going to change it. I'm going to stretch. I'm going to move it this way. This equation is y equals 2x squared. And I can see, well, it no longer goes through 1, 1. It's going to go through 1, 2. No longer goes through 2, 4. It's going to go through 2, 8, etc. Well, see, it got a little bit steeper than that magenta graph, a little bit steeper than the red. Well, can we make it any steeper? Well, I suppose we could take the graph and do this. A little bit more even. And now that would be y equals 3x squared. Now this graph may pass through instead the point 1, 3. And instead of 2, 8, well, let me see. 2 squared is 4. 4 times 3 is, of course, 12. So it's going to pass through this point, and that would be 212. So you start to get the idea. This graph starts to get steeper as this number, the coefficient, becomes greater. Of course, we could go the other way. I could say, what about a graph where a is less than 1? Now again, I'm looking at my parent equation, y equals x squared. Instead of getting more narrow, I'm going to spread it out a little more. Let's spread it this way. Let's keep going, and now it looks like we found this equation. Y equals 1/4 x squared, or x squared over 4, depending on how you like to see that. So let's see. Well, that should go through the point, and we can just calculate these all by direct substitution. 2 squared is 4. Half of that is, or 1/4 of 4 is, of course, 1. Passes through 2, 1. How about when x is 4? Well, when x is 4, 4 squared is 16. 1/4 of that is 4. It will pass through the point 4, 4. Hey, you get to see the pattern here. How about over here? When x is 6. 6 squared is 36. 1/4 of that is 9. How about when x is equal to 8? Well, 8 squared, 64. 1/4 of that, 16. So you can see where we're going. We have different shapes of the parabola based on the coefficient, and that we're going to call that the a term. Let's look at some other variations in our graphs. Well, how about when our coefficient a is less than 1? Well, that is, how about if a is negative? Let's start with our parent equation, and I want us to flip it over that x-axis. If we flip that over, it's going to look just like that. And that is going to be this equation. Y is equal to negative x squared, or you could say the opposite of x squared. After all, 2 times 2 is 4. The opposite of 4 is negative 4. Also, negative 3 squared, well, that is negative 3 times negative 3 is positive 9. The opposite of 9 is negative 9. So that's what happens if I have a negative coefficient. Let's just shim this up here a little bit so we can explore a few other coefficients. Well, let's imagine if you will, again, if I do the same thing here, I could take this equation, maybe make it more steep, pointing downward, and this one might be minus 5x squared. I can see that it passes through this point. Instead of 1, -1, it goes through 1, -5. I see. Well, let's also make one, well, less shallow, or more shallow, sorry, less steep. Move it out this way, and I can see it goes through this point. For example, 10, -5. That looks to me like we're representing negative x squared over 10, or negative 1/10 x squared. Well, let's take our parent equation, y equals x squared, this parabola, and change it again. We've made it skinnier, we've made it wider. Now we're going to take the vertex and move it along the y-axis, up or down. Let's move it up to here. Right now, it looks like I've changed the equation. Y equals x squared plus 7. 7 is the y-intercept right there. And that's going to be the vertex of this parabola, which still has its axis of symmetry right here on the y-axis. Now, we could take that parabola, and we could still, same as before, we could take that leading coefficient and make the parabola, well, let's say skinnier or wider. And the result would be, well, graphs like this. Y equals 3x squared plus 7, this steep graph with a y-intercept at 7, or this more shallow 1/4 x squared plus 7. This is the form y equals ax squared plus c. The a, coefficient of the x squared, tells me how wide the parabola is, and the c term is going to slide it up and down the y-axis. Okay, well, let's hang on. Let's restore this, and let's take this parabola and move it the other way. The only difference, of course, I say my coefficient here, or my coefficient is still 1. It passes through 0, -3, and there's my equation. And if I change this again, just like I did before, these other two equations might look like that. Notice the difference on these parabolas. These parabolas are going to cross the x-axis. Well, okay, one more case to look at in this section. And what if the parabola is opening downward? We can still use the c term. So let's start by reflecting over the x-axis. And you can see now y equals the opposite of x squared. And just like we did before, we can move this up and down on the axis of symmetry. Let's put it up here at 7. Well, right now I can see I've got this equation. Y equals the opposite of x squared plus 7. That's all there is to it. Now, just like before, we can modify this a little bit. We could make this parabola a little bit skinnier, or we could make this parabola a little bit wider. And then this is what we would have. Just like before. The a term is going to tell us how narrow or steep this curve is, and the c term is going to tell us where it is. If I just took all three of these parabolas and slid them down here, I can see right away I've got this equation as well.